In this video, we are going to find the basis for column spaces. And let's start with example 7 in the book. Find a basis for the column space of the following matrix. So if you recall, the column of A, or column of B in this case, is the span of all the columns that are in B. So where B1 is the first column, B2 is the second, and so forth, all the way to B5. B is already in row reduced echelon form, and I notice that my third and my fourth columns here, those variables, are the free variables. And I notice, if I look at this column here, B3, we see it's, let me just write down what that column is. So if I rewrite that, that is just -3 with zeros plus 0, 2, 2 zeros. And I can rewrite that as -3 times this vector plus 2 times that vector, which I realize in this case doesn't always work out this way. We'll talk about when it doesn't. This one is B2. This happens to be the vector B1, and the second one happens to be the vector B2. So I notice this relationship. We can do the same thing with B4. Let's try that. That's just going to be 5, 1, 0, 0, 0, and -1 times 0, 1, 0, 0. If I just do it a shortcut, forget that middle step. That looks like 5B1 minus B2. So now what I'm going to do is I'm going to let V be in the column of B. So therefore, V can be written as C1, B1, and so forth, all the way down to 5. And now what I'm going to do is I'm going to replace these in here. Those were extras that I did not need. So V is equal to, instead of B3, I'm going to plug this in. So B3, we know it's just -3B1 plus 2B2. So I'm going to do the same thing with B4. We know B4 is 5B1 minus B2. And we still have that last term. So now we only have a linear combination of 1s, B1s, B2s, and B5s, where the pivots were. Let's rewrite this, combining all the B1s, all the B2s, and the B5 here, so you can clearly see this is a linear combination of just B1, B2, and B5. So that is going to be our basis. B1, B2, and B5. And if we make this smaller, that tells us that B1, we know is this, B2, and B5 we got our basis for this column matrix or column of B. Let's make that a little smaller so you can see the whole thing. Very interesting. So those were the pivots, the 3 pivot columns. So there's the theorem. Theorem 13 in the book that states that the pivot columns of a matrix A form a basis of the column space of A. And you can see why here. You can see that we found some relationship where those free variables were a relationship with the other columns and were not needed. right? This was a dependent system. It wasn't independent because it was wide. It had some free variables. So you can see that this is what the relationship was. And again, we want the basis to be the smallest such linear combination. There is a warning here, though, that I wanted to talk about that's in the book right underneath Theorem 13. It says, be careful to use the pivot columns of A itself, which we did because A was already in row reduced echelon form, for the basis of the column of A. The columns of an echelon form B are often not the column space of A. And we're going to see that in example 8. So it says, for instance, in example 7 to 8, the columns of B all have zeros in their last entry and cannot generate the columns of A. So let's go ahead and look at that. So here is A. A is equal to A1, A2, all the way to A5, where this is the first column is A1, second is A2, and so forth. They let you know that this is row equivalent to the matrix B we found in example 7. They want you to find the new basis for column A, and it's not going to be. It's going to be a little different than this. So what they're telling us here is that our A is row equivalent to B. So if we row reduce this, you would end up getting B in example 7. You can go ahead and try that on your own to see if that happens. But notice how, right, the basis for A is not B. It's not the same as example 7. It is going to be those pivots. So the basis for B, so the basis of A, I'll call it beta of A, is going to be the first column there, the second column, and finally the last column, those pivots. Because the other two equations are free variables, so that relationship, that was hard to find, but that relationship still holds. Which, by the way, are A1, A2, and A5. If you look at their solution, you can see that the relationship between B3 with B1 and B2 and B4 with B1 and B2 are the same. Right? We can check those. Let's just visually check this one. So if you take negative 3 times A1, that's negative 3, plus 2 times A2, that would be 2 times 3, which is 6. You would get 3. You can do it all the way through here. Negative 3 times negative 2 is 6, plus 2 times negative 2, negative 4, it's 2. It works. And you could do the same thing with A1 and A2 with A4. So you can check that it is true. That's what they say. So by the same argument, right, you do not need those, but you don't call them. Also, A1 and A2 and A5 must be linearly independent, but you have to use the A1, A2, and A5, not the B1, B2, and B5. So let's look at some problems in the book. Let's look at number 23 and number 24. It says here in the directions, it says exercises 23 through 26 display a matrix A and an echelon form of matrix A. So they're not even making you find the echelon form. Find a basis for the column of A and the basis for the null of A. So let's do the column of A first. So we know the column of A is where the pivot points are. So here's the echelon form. So we know that the basis for A is the first two columns, but you have to use the original A. So the basis for the column of A is the first column, 4, 6, 3, and then the second column, 5, 5, 4. For number 24, this is a 1 with zeros. x2 is free, the second column. Here's a 4, but it could change to a 1. So the two pivots are x1 and x3. So it's going to be the -3, 2, and 3, with the third column, -2, 4, and -2. I was worried for a minute because it was looking similar, but they have that negative there. That should be the basis for the column of A for number 24. What about the null? If you remember, the null was where the free variables are. So the null is going to be where those free variables are. So let's look at 23. The null, so again, this was the pivot, this was a pivot, so it's going to be something to do with x3 and x4. If you recall from the last video, the null of A, if you remember, is the set x where ax equals 0. And so we have to draw a line here and get a 0 there, and we can actually solve. But since there's free variables, I'd rather there be a 0 here, so it's not in reduced echelon form yet. So I'm going to go ahead and take my A, which is equivalent to this, and change this to, I'm going to get a 0 there, so I'm going to make this a 0. And then that would be a -10 plus 6. And finally a 12 plus -5. And then I'm going to now solve. So x1 we know is 4x3, because this would be x1, and x4, minus 7x4, and x2 is equal to -5, because again we're really solving with zeros here, so it's -5 x3 plus 6x4 plus 0. And if I write this in parametric form, I can replace x1 with what we found here on the left, and the same with x2, and leave the x3 and the x4 alone. So I'm going to get that this is equal to an x3 times all the coefficients of x3 are 4 plus 4 actually. A 4 still doesn't look like plus. -5, 1, and 0. And x4 is going to be -7, 6, 0, and 1. And that is the basis. The basis for the null of A is this column and this column. So now let's have you try number 24. Number 24 is up here. If you go ahead and pause it, what do we want to do with 24? If you remember, we already found the basis for the column of A, so now go ahead and find the basis for null of A. You can pause and come back when you're ready, and I'll display the solution for number 24. Okay, the solution. Here it is. Number 24. You can see here the basis for the column of A we've already done. It's right here. So we're going to check that out with our answer, and it's the same. To find the null of A is a little bit of work. If you remember, the null of A is where ax equals 0, so that's what they did here. They changed it to reduced echelon form to make it easier for them to solve. Once they solved it, they put it into parametric vector form, and these two vectors is the basis for the null of A. And that's it.